been asked to write the decay function and solve for t. So the first thing you should do is just, if you don't remember it, go back and look in your text from lesson 81 and just write it out. So we have n of t is equal to n sub 0, which always means, remember this sub 0 means the original amount, and then we have e to the negative kt. That negative implies that there's decay going on, okay? That k represents the constant. So now we can start plugging values in. When we plug those values in, we're going to get 0.3. Here we're going to get 1. Then we have e. K is equal to 0.0974. So we have my negative 0.0974 times t. So now we're solving for t. Well, divide both sides by 1, right? Okay, which if you do that, you're going to get 0.3 equals e to the negative 0.0974 t. You need to take time to write these steps out because that's how you'll get good at remembering what's going on here. Now, remember that if you do the same thing to both sides of an equation, it's perfectly legal. As you may recall from when we worked with logarithms, we were allowed to take the log of both sides. So we're going to do that with the natural log. We can take the natural log of both sides. Now, the natural log of 0.3, there's a value for that in your calculator, okay? So we can actually solve for that here in a minute. Now, let's take the natural log of this thing, and that gives us negative 0.0974 t again. Now, I'm going to take you back to what I told you a little bit ago in an earlier video. Remember this understood base is e, okay? So again, when you have, if these two values are the same, what this is asking is e raised to what power will give you this? Well, it'll give you itself. Remember when we say if you say the natural log of e to the 7th, basically what you're saying is e to what power? E to what power will give you this? Well, it'd have to be e to the 7th because e to the 7th equals e to the 7th, okay? So it's that idea that we're using to allow us to say that this whole big mess right here actually ends up just equaling negative 0.0974 t because we took the natural log of both sides. See how this base is the same as this number right here? Okay, so then we have the natural log of 0.3. Now you can just solve for t. Divide both sides by negative 0.0974, and this is by negative 0.0974. And when you plug this divided by this into your calculator, you should end up with t equaling, I think I got 12.36. Now, I don't know if that's minutes, months, days, years. I don't know what it is for time, but that was not the point of the exercise. Anyway, they wanted you to get familiar with working with this exponential decay with natural logarithms.